Okay, Michael Landis here with Forsyth Technical Community College. Today we're going to take a look at EGR valves. I have a vehicle here that has an EGR valve on it, and I also have a EGR valve that is off of a vehicle that we're going to take a look at. This is my 1998 Dodge Caravan. And we'll take a look at this thing and see how the EGR valve works on it. This one is computer controlled. It is also back pressure. So here's the EGR valve. So here's the transducer for the EGR valve. The EGR valve is actually down here underneath of the intake, and you can see it right here. And let's see if we can put a little bit more light on that so you can see it a little bit better. So that's the EGR valve. It actually screws into the intake manifold, so it's bolted to the intake manifold. Two bolts hold it in. By the way, when you're servicing it, they do tend to strip out when you take them out, so you need to be very careful removing them, or you might have to do some thread repair. Underneath of it, if you can see underneath of here, let me see if I can position this light so it'll stay there, and then I can point out the piece, though it is hot. Let's see if I can get this in here. Okay, lit up right down here. Right there you'll see a tube coming out of the intake manifold. It has two bolts hooked to it. That tube goes down to the exhaust manifold. That's where our source for our exhaust gas is going to come from. So it's not uncommon for those tubes to become clogged and have to be cleaned out. On some vehicles that's fairly common. On our EGR valve over here, here's the way this works. This is pretty much a standard EGR valve by itself. So it is going to, and I'll use this as a little pointer. There's our EGR valve. It is going to simply be vacuum operated on this particular style. There is a vacuum hose that hooks to it right here at the very back side, and I don't think you can see it in this camera because this wiring harness is in the way. This wiring harness right here is just blocking the hose, but I'll show you where that hose ends up. So when you apply a vacuum to it, it's simply a valve. It opens up, the vacuum pulls on the diaphragm against spring pressure to open it up, and it allows exhaust gases to flow from the exhaust manifold that is going to have anywhere from about 1/4 of an inch of vacuum to about maybe 1/4 to a pound of back pressure. So the intake manifold, while this vehicle is at cruise, is generally going to have somewhere around 10 to 12 inches of vacuum in it, so that slight pressure in the exhaust, or even that slight vacuum, is still much greater than the 12 inches of vacuum that we have in the intake. So that's going to allow that pressure to move into the intake manifold, and in this case it's mixing it right here, right past the throttle body is where that hose hooks up to. So it gets mixed with all of the air that's going in. Now this valve opens by vacuum. So if I can get to where There's the valve. There is a hose that hooks onto it. The hose comes right up here. It's right here at my finger, not the wiring harness, right underneath of that. There's the vacuum hose that goes to the valve, and it goes to this piece right here. And I'll see if I can get that lit up halfway decent for us so you can see it. So it goes right here. That is a component called a backpressure transducer. What it does, it has a hose on the back side of it that hooks up to the bottom of that EGR valve, basically right into the exhaust. It's going to make sure that we have a small amount of pressure in the exhaust, because what we do not want to do is to open that up, find out that the intake manifold is at wide open throttle and might be at 0 psi. In that case, if I have a slight vacuum in the exhaust, we will end up letting oxygen into the exhaust system, and that will affect the reading of our O2 sensor. The other thing that it does is it makes sure that there is a slight vacuum there, or pressure in the exhaust, to open the valve up so that it can actually work. It's just a small spring-loaded diaphragm, has a very small spring on the bottom of it, has a solenoid on the top of it. Now the solenoid only controls vacuum to the transducer. So if the computer, this is the solenoid, this round piece on top that's lit up, and if the computer decides it does not want EGR function, we don't need any EGR, then it's going to energize that solenoid and it's going to block vacuum going through it. So in this case, this solenoid, when it is de-energized, vacuum can go through it. When it is energized, vacuum does not go through it. That way you cannot unplug it just to shut off the EGR. It makes it harder to disable this system, because if you unplug it, you're going to get a code. If you disconnect it, the vacuum source to it, it'll fail the monitor and you'll get a code. So when we want EGR, generally light load, light to medium load, not working real hard, we're driving down the road, the conditions are right, it will have, most vehicles, temperature out of the engine is going to affect it, the load that it's under is going to affect it. The computer will decide if we're under a condition we could be creating NOx, it's going to allow EGR. Then we're going to apply a vacuum to it, and this vacuum hose goes straight to intake manifold vacuum, so it's not before the throttle plates. This one on top of the throttle that you see, it's what we call a ported source. We only get vacuum there if the throttle is open, but this one, the vacuum hose goes directly to the intake manifold, so it has vacuum all the time. So the computer decides we need EGR. We turn the solenoid off. That allows vacuum to flow through if we have a slight amount of back pressure in the exhaust. If we do not have a slight amount of back pressure in the exhaust, then the transducer will not allow EGR. So that's what the transducer is there to do. It's to help modulate the amount of EGR that we're going to get, so we can control it a little bit better. Without that, you get the same amount of EGR regardless of what's going on. If there's enough vacuum to open it up, you've got EGR. And in some cases, we don't want full EGR. We just need a little bit. It's all calculated by the engineers and programmed into the computer. Now, outside of the vehicle, I have a EGR valve here. And I'm gonna sit down here next to my planting bed. This is our EGR valve. And this one is just a little bit different. It has a casted bottom on it. It's cast. It is made out of cast iron. It'll take the heat. And the bottom end right here is actually bolted to the exhaust. So we're going to bolt this to the exhaust system. The top one right here bolts to the intake, and the valve is right in here. You can see the molds, so they come together right here, and the valve actually sits right here in this area where my thumb is. We have a vacuum port right here that we're going to hook vacuum up to, right underneath of here, and I'll show you this with the camera here in just a minute, is a vacuum diaphragm. So you can actually see the vacuum diaphragm move up and down. And this one, a little bit different than some, we have on the top of it is a sensor. So this one, the only way we're going to restrict the amount of EGR that we're getting is down here at the bottom. They put a restrictor in the intake port here, or the port that's hooked up to the exhaust manifold. So that would be the intake. So our exhaust is going to flow into this port, come up through here, and then go out to the intake if the valve is open. Now the valve will vary the amount of EGR that we can get, but this restrictor is going to decide how much we can get. So our restrictor decides how much we get. The valve up here is also going to decide how much we get, but generally we're going to control it by a solenoid here. We also use this for diagnosis of it, because if this thing is stuck open, we can set a code for that, because now we can tell. That used to be a big problem with these, is they would stick open. Now the car didn't want to idle because the exhaust gases are taking away enough of our air fuel mixture that we don't really have enough to keep the car running real well. So to catch that fairly easily and diagnose it to see what happens, and to make sure that it actually works when it's supposed to, we put the sensor on the top of it. This is just a plain old potentiometer. If you look right here in the connector, I think you can see all three of them. There's 3 wires, so one's going to go to 5 volts, one's ground, the other one is our sweeper arm, and it just tells us where this sensor is.